Hi, everybody. We're back. We just finished doing the circulatory system, right? Remember, the job of the circulatory system is to get everything that your cells need to your cells, right? Oxygen, nutrients, water, salt, calcium, anything that your body needs. That's how it gets there. Your heart pumps the fluid that we call blood around to all of your cells. Well, your cells need oxygen, right? They need oxygen. And if you remember, we did cellular respiration. Your body cells need oxygen because you need to get energy to do to do all of your bodies and all of your cells functions. And when your body undergoes cellular respiration, remember one of the waste products is carbon dioxide, and you have to get that out of your body. So when you think about the respiratory system, the big thing is the lungs, right? That's the main organ. And so you need to get oxygen into your cells because you need it for cellular respiration, and you need to get oxygen out of your body from your cells because it's a waste product of cellular respiration. So in order for you to have energy, it has to undergo that process, and there are waste products, and you need oxygen to do that. And so when you look over here, when you're looking at, let me see if I can get this. There we go. So when we look at this is the basic structure. So lungs are the big thing, right? That's the main organ. Then you have the diaphragm, which is like a a material. It's almost like I don't want to say like a rubber sheet, but it sort of kind of is. It goes down and up as we breathe in and we exhale, and we'll look at that in a second. So your nose is part of that, right? Nose is where the oxygen comes in typically. Mouth, it can come in that way. It goes down the trachea, right? So the trachea is that bony bit in the front of your throat. The esophagus is behind the trachea. Okay, so you don't want food going down this goes to your lungs, right? And if you are messing around or you're not paying attention or you start laughing when we say it went down the wrong pipe, we mean it went down the wrong pipe. So instead of going down the esophagus, which goes to your belly, it went down your trachea. And when you get food into your lungs, you can get major infections. Okay, so trachea, and then the trachea goes into bronchioles, which are down here, and they go into your lungs. And your lungs have like little sacs called alveoli all in them. And when you inhale, they expand. When you exhale, they contract. And we'll take a look at that a little bit later. So those are the main parts of the respiratory system. And down here, there's a little fun fact that talks about the fact that you breathe anywhere between 15 and 25 times per minute. So if you're sleeping, your respiration is breathing. Cellular respiration is different. Remember, they're not the same thing. So your respiration rate, if you're sleeping, is on the lower end. 25 is typically normal, but if you're running a race, man, your respiration rate's going to be way higher, right? And remember when we did cellular respiration, remember we had that athlete, right? Was breathing really, really hard. Well, why is that? He's breathing really, really hard because his body is pumping the blood faster, because his cells need more energy because he's exercising, and it needs to get the carbon dioxide out. So his heart's pumping faster because he needs more oxygen. He needs to get that carbon dioxide out faster, right? So remember, those two systems are very difficult to separate. So when we go on to the next slide, we look at the lungs as the main organ, right? And so we still they're doing blue and red. Remember, they're not really blue and red. It's just that the red is oxygenized and the blue is deoxygenized, right? And so we have over here it's not labeling it, but underneath you have what's called the diaphragm. And in the next slide, we're going to look at what happens to the diaphragm when you inhale and you exhale. Okay, so remember that your skeleton protects your ribs, especially protect your lungs, right? And so as you inhale, your skeleton has to expand a bit, right, to allow for the expansion of your lungs. So don't forget about that. Remember, all of these systems work together. That little fun fact down here, it says if you hold your breath for too long, your brain will force you to breathe. Now, if you babysit little kids, they always think they're really slick and like, oh, I'm going to hold my breath if you don't let me do something. You know what? Make sure that when they hit the floor that they're not going to get hurt. But as soon as they hold their breath, if they pass out at all, they're going to wake back up because their body is like, uh-oh, kid's not breathing. So the brain will actually force you to breathe. And then the kid wakes up and he didn't get what he wanted. So don't give in. Next one is on the next slide. And so I have a couple of different GIF files here. I do love GIF files. And so you see that let's look at what happens when so the arrow is going to be coming in. That means the arrow is coming in, right? And so it makes sense. So this is the diaphragm that I was telling you about, that very flexible material underneath your lungs. And as you inhale, right, your lungs expand and you have to have more room in your thoracic cavity, right, in your chest. So what happens is you inhale, and as you inhale, it pushes down that diaphragm. Now look what happens when you exhale, right? It almost helps to push the air out. So when you exhale, your lungs are getting full. It has to push that floor down, and when you exhale, the floor comes up, helps to push the air out. Okay. And this next little GIF file here, you'll see that the lungs are expanding when they're inhaling. They are contracting when they exhale. So he's inhaling, exhaling, inhaling, exhaling. And then this should look familiar to you. So this is the same GIF file that I had in the circulatory system screencast. And the reason why I'm using the same one is because it has a good picture of the lungs and where is that darn blood coming from, right? Well, the blood that has come from the cells, remember, goes into the right part of the heart, right? It goes into the right part of the heart, goes into the atrium, and then into the atrium, and then it goes through that valve, and it's in the ventricle. And then the ventricle pushes really, really hard. It pushes it up into the lungs. And so here, right, the deoxygenated blood is going to the lungs. The lungs are going to oxygenate the blood because they're going to throw out the carbon dioxide. As they're breathing, we're going to take in oxygen. And so notice that there is, from one side of the heart, remember, one side of the heart is pushing in deoxygenated blood that came from the body. It's going to the lungs, picking up oxygen, getting rid of that carbon dioxide. Okay. So the next, I think there's one more slide, a couple more slides after this. So I'm sorry, as a science teacher, I can't not take this opportunity to diss smoking. I'm sorry, I just can't do it. So in your lungs, you have things called cilia. Okay. Now, if you have healthy lungs, those cilia move really, really fast. And what they do is they help to push dust and pollen and foreign things that don't belong in there, including germs, by the way. And they're supposed to work, and they're sort of like feathery, right? And so when you inhale, if you are in a dirty environment, right? So say you're cleaning the barn, there's all kinds of dust and stuff. And so your cilia would be helping to keep that stuff out of your lungs, right? Well, guess what? If you smoke, those cilia die. And so that's one of the reasons why people that smoke tend to have more lung issues. It's one of the reasons, because this is a line of defense. This is supposed to be keeping them healthy by keeping those foreign particles and germs from getting into the lungs, right? And so keep your cilia healthy. Now I'm going to show you something, and I'm sorry, it's going to creep some of you out, but that's okay. So there is a thing that you can buy for science class, and you're probably going to see one in your high school. And so these are, in this gift file right here, what you see are two sets of pig lungs. Now, pig lungs look the same as human lungs, except they're smaller, basically. And so what they've done is they've treated these lungs. So the pink lungs, and your lungs should be pink if you don't smoke, because anything that you inhale has particulates. And so it can get in your lungs. And if you've smoked for any length of time, you literally have black lungs. It's not a pretty sight. The great thing is, though, if you started smoking and you quit, your lungs will clear up to become pink again. The bad thing is there are people that only smoked for a year or two, and they're like, 20 years old, and they get lung cancer. And we don't know why. There are people that smoke for 50 years and don't get lung cancer until they're adults, right? Like really old. And then there are people that only smoked for a couple of years, and we don't really know why that's the case. But the good thing is, if you quit smoking, and no matter what your age is, and there's not any cancer that has started, or any long-term damage, it actually can be reversed. So if you started, stop. All right. So now that I just sounded like a parent, I'm sorry. But if you started, stop. I'm going to click on this guy. I'm going to click on this link right here because I want you to see this. He explains this. So I'm going to click here. I'm not going to show it to you. You're going to go and you're going to do that. You don't need me to talk over him. So you're going to click here if you want to see it. It's a really good video. And they're explaining what happens when you smoke in terms of the elasticity of the lungs and everything. So I think we're going to stop there. And so that's the end of the respiratory system. So I hope that this is starting to make sense to you. Remember, the circulatory respiratory system work really, really closely together. And again, all of the systems do. So I hope this makes it clear, and I hope I'm jazzing you up for biology because it's really fabulous. So you have a great night, and next time.